Okay, shall we start? So, how the data will be? Hope you are able to see my screen. Yeah. So, how the data will be stored in a block, right? What exactly this block will does? So, before going to see that the block concept, so we need to understand the cryptography concept. So we have many cryptography algorithms, and using that algorithms, we can generate a hash code. Okay, say, let us assume if I have a string hello. So if I apply any hash algorithm on that string, so the data or the output will be in a hexadecimal format. Okay, so the hexadecimal format, whatever it is, always it will give a fixed length. It is generally about 32 bytes. So this output, whatever we are getting, this will be the final output. And let me show you how it will be applied. So suppose if you give hello, so the hello, it will be converted as in hexadecimal format. So internally, there is a cryptography algorithm applied on this data, and it is given the output like this. So this output, we can call it as hash code. So this hash code will be always a fixed length, and if you just change the data, it will be a huge impact. And whatever data you will give, the size of the length of the hash code remains same. It is 32 bytes. And if you enter even 1 GB data or 1 terabyte, so the output, it is always the fixed length. But you cannot get, this output is a unique, and it cannot be repeated. Okay, so this hash code, whatever we are getting, it will be linked to the next block. So here, if you observe, if once we create any block and if we apply the cryptography algorithm, so the hash code, whatever we are getting here, this hash code will be linked to the next block as a previous block hash code. Okay, so how the blocks will be interlinked with the help of previous hash, okay, previous block hash code. So say, let us assume in this block there are about 100 transactions, and here another 100 transactions, and here another transactions. So all these 300 transactions recorded in the blockchain, and how the blocks will be linked each other. So block 1 and block 2, how the connectivity is established because of this, with the help of this block hash code, right? So this hash code, suppose tomorrow, if there are 3 blocks in the blockchain and 300 transactions are there, and tomorrow someone else wants to modify the first block data, some hacker or any internal administrator. So even if he touches any of the records, so the hash code will be modified, and this hash code will not fit to this hash code. So automatically the link will be disconnected between these two blocks. The link will be disconnected if someone else modified this record, right? And not only this one, there are other mechanisms. So that mechanisms we'll see it in tomorrow's session. At least we can understand the basics of this blockchain concept. Okay, the major important thing, it is hash code, and the advantage of this hash code is, suppose if someone else touches any record, even a single dot also, the hash code will be modified and no one else get the original data based on the hash code. It is not reversible, right? So there is no mechanism. If you give based on this hash code, it will not be generated back the original input, right? So that is another advantage. So tomorrow, if anyone changes at least a dot also in the data of the existing blocks, so automatically the hash will be, new hash will be created, and this hash will not be fit for this hash. It will not be compared. When we compare this hash and already hash whatever it is in the second block, so it will not be matched and automatically the link will be disconnected. And just think that if a blockchain is a book, okay, so if a blockchain is a book, and you can think that each book, each page in the book is a block, right? So each page in the book is a block, and each line in the page, you can call it as a transaction. So this is the hierarchy. So transactions will be stored in the blocks, and blocks will be added into the blockchain. Okay, with the help of the previous block, with the help of hash code. So this hash code will be linked to this block, and this block hash code will be linked to this block, and this block hash code will be linked to this block. Say, let us assume now there are 4 blocks and we are at block number 3. So suppose if someone else modifies second block, right? So the link will be disconnected from the third block. Why? Because block number 2, whatever it is generated, the newly hash code, this hash code is not matched with the existing, the third block previous hash code. Okay, and togetherness of the second block transactions plus the hash code of this entire one will be added, added over here in this hash code. Once again, I will repeat. So say, let us assume there are 100 transactions in second block, and this block hash code will be whatever the hash code, it will be used in third block, right? So the second block hash code is nothing but the first block hash code plus the data of the second block. So here there are 100 transactions. So this 100 transactions data plus the first block hash code will be generated the output of this second block. Okay, and again in third block, the second block's hash code plus the 100 transactions of this block, this will be generated as a hash code. So each block you can give, each block you can identify with a single transactions, that is single code, that is hash code. So tomorrow I will go in depth of these blocks and internal concepts. Just I will show you, for our easiness, I will show you the live hash codes, how it will be generated. Say this is the live operations of the Bitcoin, and Bitcoin, Ethereum, Ripple, these three are the topmost cryptocurrencies, and this is the current data, whatever we are seeing, it is live one. So when we observe this blockchain, the Bitcoin Explorer, these are the transactions in a block, right? So this is the current block, and the current block hash code is this one. So the hash code, always it will be in a hexadecimal format, and hexadecimal is the combination of 0 to 9 numbers and A to F alphabets. So this block contains about 1493 transactions. Okay, so this is the latest block in Bitcoin. So tomorrow we'll go in depth of the Bitcoin and Ethereum as well. And when you just click on this block, the transactions are here. And if you want to see the transactions also, you can able to see, and all these rewards, everything we will see it in tomorrow's session. Yes, just at least you understand the output of any block, it will be represented in this hash code. Whatever data you give, 1 GB of data or 1 TB of data, the hash code size will remain same. It is about 32 bytes. And there are some cryptography algorithms like SHA-256, SHA-512. So these cryptography algorithms are pretty old, and we are using that algorithms in the blockchain. Okay, so anyway, we'll come back to the slides. So tomorrow we will see how the data will be stored in the Bitcoin and how the Bitcoin transactions will be performed. So in terms of block, we need to understand there will be a data in the block. So data is nothing but the transactions, and hash, the data plus the previous block hash, we can generate a fresh hash of the block. And also it will link the previous block hash. Already we have seen this slide. So tomorrow, if anyone tampers the data, so that link will be disconnected from that block. Suppose if someone else modified, whether it is external hacker or internal database administrator, if they try to modify the data in the block, so the link will be disconnected from that block. So if there are 3 blocks and someone else modified in block number 2, so the chain, whatever it is, 1 and 2 will be valid, and from 2, the data, the link will be disconnected. So this is another slide to explain the one. So H1 is the hash code of the block 1, and H2 is the hash code of block 2. Here, H2 contains H1 hash code, that is the previous block hash. So like this way, the link will be go on. So this is the block number from the Bitcoin. It is about 555. 585K. Okay, so about 5,85,162 blocks are there in current Bitcoin blockchain. Okay, so from last 10 years, if you observe, these many blocks created till this point of time. So 5,85,162 blocks. So tomorrow, if anyone try to modify the data of this block, so the link will be disconnected from this block, and it will not be proceed further. And tomorrow we will see how secure the data, and what are all the other architecture of the blockchain, and togetherness of many computers. So we will call it as a blockchain network. So currently about 35,000 peers or nodes are there in Bitcoin network. So 35,000 nodes are peers across the globe. So Here, if anyone tries to modify the data, definitely in the validation part, the other nodes will not accept the modified the data or the tampered data. So that we will see it in tomorrow's session. Anyway, we'll continue the internals of the blockchain. So this hash code, you can imagine it as a thumbprint of human being. So how unique our thumbprint. Okay, so definitely each person has a unique thumbprint, and likewise the cryptography algorithms, whatever SHA-256 or SHA-512, so these algorithms will generate a unique hash code. So whatever hash codes you observe in this network, so these hash codes are unique. So not only blocks hash code, we have transactions also. For each and every transaction, we have a hash code. So all these hash codes are unique. So definitely it is highly impossible to get same hash code for two different inputs. And also we have encryption and decryption mechanisms. So the point is here, whenever you pass any data in a secured way from one node to another node in the network, so we need to use this encryption algorithm with the help of private keys. Maybe session number 5 or 6, we are going to deal this encryption, decryption more in depth. So how we can pass the data in a secured zone from one computer to another computer or one node to another node in the network. So here encryption, whatever data you encrypted, you can decrypt it with the same key. Okay, whereas in hash code, it is not possible to decrypt, or you cannot get it back the original input. Suppose if this is the input, and if you apply any cryptography algorithm on this data, so it will be generated a hash code like this, and this hash code you cannot get it back. Using this hash code, you cannot get it back the original data. Whereas in encryption and decryption, that is possible. Okay, while during data transfer in the network, it will be in the decrypted manner, and the receiver will get the original content. Okay, with the help of same private key. Whereas in hash code, that is not possible. So these two mechanisms are providing us the data security. So number one, it is hash code. Number two, it is encryption and decryption. We'll go this more in depth somewhere in session number 5 or 6. So think that what is an immutable ledger? So current ledgers, majority of the ledgers. So ledger is nothing but our bank statement, right? So our bank statement has set lots of transactions. So someone else maybe modify this transaction. There is a chance, right? So from the bank end also, not only from the external hackers, so internal administrators, they can touch the data, they can tamper the data. That is different story. So they can caught in the audit. That is different story. But before caught that or before audit, so some damage will be happened, right? In PNB case, it's happened. So about 9,000 to 10,000 crores they lost. So if blockchain was placed in their banking system, definitely it will that type of scams will not be possible. So let us assume this is our current system. So when we want to exchange a property, so here we are exchanging the property with the money, and there is a legal department involved, that registration office, and they will issue a deed or the land title. And this transaction, whatever happening in current system or the traditional ledgers, say let us assume it is recorded in the books of the registration office or the traditional databases. So there is a chance to delete the page or to delete the transaction or to modify the transaction by someone else, whether it is the internal administrator or from the external hacker. So this is the current issue in the traditional ledgers. If the data is recorded on the blockchain, so if someone else tries to modify after some time, if someone else tries to modify the data, definitely the hash code will be, new hash code will be generated, and that hash code will not be matched with the next blocks. So automatically the link will be disconnected over here, and also the data will be in distributed manner. That is the advantage. Whereas in centralized databases like Oracle or SQL Server, these are all the centralized databases. Whereas blockchain is a decentralized database. So in centralized databases, the issue is there is a chance to modify some central authority. Whereas in blockchain, the data will be in distributed manner, and if you try to modify this one in your computer, the same data will be there in other computers as well. So we'll see that one in the next slide. So here there is a network concept involved. This network, we'll call it as distributed and decentralized peer-to-peer network. So before going to this slide, I would like to show you the current the current architectures. So majority of our web-based applications or mobile-based applications, now they are using this centralized architecture. So generally in the centralized architecture, we have a server or minimal number of servers, and around these servers we have many clients. So if there is any issue in the central server, so automatically the services will be stopped, the business operations will be stopped. So about, I think, 2 months ago, the major airlines got the same issue. So they got downtime about 4 hours, and the impact was around 2 days. That the delay of the 4 hours, the stoppage of the 4 hours impacted about 2 days of their business operations. So many people got some difficulties. So if we move that systems from centralization to decentralization and distributed, so definitely you can resolve the downtimes, and you can resolve that hacking concept also. So how we can resolve that hacking concept, we'll see. So blockchain is using this decentralization and distribution concept. So here there will be many servers, and each server is, they can communicate with each other, and also each server, they can maintain same replica of data. So suppose if someone tampers data over here, so the other systems in the network, they have their own copy, and if he tries to modify this one, and he has to broadcast the data, whatever he tampered over here, to all the other systems also. So you need to inform the data about all the other systems. So other systems, they will verify whether this person is having any tampered data or not. If it is genuine data, then only it will be updated in all the other systems. Otherwise, it will not be updated. So that we will call it as consensus mechanism. So that we will see it in tomorrow's session. So how consensus will be used. So this is another diagram to understand the differences between centralization, decentralization, and distribution. So now in blockchain network itself, we are not going to use centralization architecture. Here we are using decentralization and distributed networks. So coming back to the slide. So here, if someone tries to modify the data in his machine or any node, so no problem, he can able to modify it, and he can able to generate a fresh hash codes for all these things. But the thing is, in the blockchain, the data, whatever it is modified, we need to broadcast to the other nodes in the network. Okay, so when we broadcast this data to other nodes in the network, definitely the other nodes, it will first verify and validate the data, whatever that newly broadcasted data. If it is genuine, then only it will be added. Otherwise, it will not be added. So when we come back to the features of the main building blocks of the blockchain. So togetherness of all these things, we'll call it as blockchain. So we are applying the cryptography algorithms for the data security, and also we are using immutable ledgers. So the data, whatever it is recorded on the blockchain, it will be immutable. So, and if someone tries to modify, that should be informed to all other nodes in the network, and all other nodes, if they approved, then only it will be impacted. So that is highly impossible. So that's why from last 10 years, we didn't observe any hacker attacks on Bitcoin application. Okay, so we need to understand the power of the blockchain technology in the Bitcoin application. So maybe that is different story. So Bitcoins are highly fluctuated. So it was started with few cents and it touched about 16,500 USD, I think. And from there again, it comes back to around 3,500 USD. And now from 3,500 to it is reached about 12,000 USD. That is different story actually. But the beauty is,
hello, negative.
the beauty is you understand no one is control the network of Bitcoin. So there are no central administrators, right? So though it is a public blockchain network application, so public blockchain network application, private blockchain network application, these are the different types of applications in blockchain that we'll see it in next class. So in public blockchain network applications, there are no restrictions, right? So anyone can join as a miner or node in the network. So tomorrow, if you and I wants to join in the Bitcoin mining operations, so definitely we can join. And once we join, we can try to tamper the data, but the data should be accepted by the other nodes in the network, right? So that is the internals of the Bitcoin operations. So that will go in depth in next session. The thing is, just at least you need to understand hacking is impossible in blockchain. Okay, why? With the help of this shared and immutable ledger concept. Okay, so the data will be shared between the nodes, and here we are using different network architecture. So no more centralization in blockchain. So it will be decentralized and distributed peer-to-peer network. So here the communication will be peer-to-peer. And also if there are any downtimes or if there are any issues from few nodes from the network, no problem. So other nodes will be running. So that's why from last 10 years, we haven't seen any network issues or any downtimes in Bitcoin application. So if you observe, it is running, this application is running 24/7 and 365 days. So no stoppage. Even in our stock markets, it will run only few hours, but these cryptocurrencies are running 24/7 and 365 days. So no holidays actually. Okay, so how it is possible? So how it was not affected by any hackers, or how it was not affected by any downtimes? Okay, so the background for this application, it is Bitcoin, right? So tomorrow we'll go more in depth about this one, and let me complete. Few more slides are there. So we'll go more in depth about how what are the advantages, and all these 5 features we can see it in next session. Just we'll try to understand majorly 3 things. Number 1, it is a network. So this network is a newly created, what we call new architecture. Though these concepts are pretty old, but we are using the real power of decentralization and distribution. And this is Genesis block. So the first block in the blockchain, we'll call it as Genesis block. And what is the future of this blockchain? So this this diagram comes from the Statista. So the global blockchain technology market somewhere between 2018 to 2013 in USD billion. So it is, I think, as per my knowledge, it is going every year. It is going to double. 100% growth is there. Okay, so from 2018 to 19, 19 to 20, if you observe till 23, so it is, there is 100% growth. Okay, and also in this diagram, this was published by Gartner. So Gartner, they just for the next 10 years, they forecasted it, and they divided the phases in the blockchain. So up to 2021, and from 2022 to 26, and 2027 to 2030. See the graph. So the boom will be started slowly, and definitely there is not much usage of the blockchain, but in future, definitely this is one of the prominent technologies. And in terms of the technology usages, so blockchain started at low point, maybe in next 5 years, so definitely it is going to reach at least top 1 or 2 places. So the intermediaries, so whatever the current banking system or any other systems, so the mediators, they can have some capabilities. So if Indian central government, if they want to control the money flow, definitely they can take some charges, whether they can increase the rate of interest or decrease the rate of interest. So the money flow, definitely they can control it. So if there are no intermediaries, so there may be some other advantages. So that advantage we can see it in tomorrow's session. But the thing is, so using blockchain, you can cut down the mediators. So you need not to depend on any mediator. So obviously you can see the real benefits. So in Bitcoin, no one is controlling the money. So it has their natural flow and it has their own advantages. So whereas in US dollars or Indian rupees, the flow will be controlled by the corresponding central governments. So this is the diagram where we can see in the current traditional system. So if you want to exchange a property, there were many mediators involved, like lawyers or registration officers or brokers or insurance companies. So now if we move that system, this transaction onto blockchain, so instead of the humans, we can place the computers. So that is the main motto of fourth industrial revolution. So you can decrease the human involvement and increase machine-to-machine involvement. Okay, so in next further classes, we can see how the machines is replaced with the humans and what are the advantages. So here in fourth industrial revolution, there are many other technologies, so but blockchain is going to play a major role. So this diagram explains the current system of getting the ownership from one person to another person. Say, let us assume any property, say it is a car. So anyway, I'll go more in depth about this example in tomorrow's session. At least we can try to understand. Because of the limited time, I'm not going to explain the more in depth. This is one of the best use case. So how we can compare the traditional systems and when we replace the blockchain-based systems. I like this diagram. At least we can, as a fresher or as a beginner of the blockchain, we can easily understand. So tomorrow I'll spend some time for this. So in supply chain management, there are many parties involved. So if a goods exchange or shifts from one location to another location, there were many participants involved. And what are the advantages if we use blockchain over here? Okay, right from the farmers farming to the kitchen. So definitely you can track the goods or the vegetables or anything. Okay, so this one also we can see it in tomorrow, and how we can execute the transactions. in blockchain. So there are some steps involved. So how you can create a transaction. So transaction is nothing but like your bank transaction, but so transaction is not only money related. So you can do any business activity. So suppose if a medical shop person, if they want to maintain the stock incoming and outgoing, that is also a transaction. Okay, so whatever transactions you placed in the ledger, so that ledger should be in a secured zone. And here, how the ledger and how the transactions will be created in more effective with blockchain, we'll see it in tomorrow's session. And there are many frameworks involved in the blockchain. So majorly Ethereum and Fabric and Corda. So maybe in next week we will see what is Ethereum and what is Fabric. Majorly using these frameworks, you can build the blockchain-based applications. So in development point of view, there are frameworks. So when we learn these blockchain technologies, we need to understand in two views actually. One is the management point of view. Second one is in development point of view. Okay. So at least if you understand the concepts, so we can speak in the circle and at least we can understand how the future will be. So what type of applications we will be able to see. Okay, so we have another 2.5 minutes. So if you have any doubts, just you can ask. Otherwise, you can mail me or you can call me on my number. So definitely I can able to answer. So for today's session, I would like to conclude over here. And tomorrow also we'll start at 7. And I will try to explain some more in depth about the blockchain, and we can just correlate with Bitcoin application. So we are not encouraging Bitcoins. So just we are trying to understand how the Bitcoin application is more powerful with the leverage of blockchain technologies. So please mail us. So I would like to share my Google Drive. So there are a couple of books I have. So and some content is there, and it is a regular process. Whatever I feel which is useful to you, I will add up in the Google Drive, so that you can at least go through that one.
This is Natraj here. This is.
Sorry, your voice is breaking. Oh, okay, no problem. Yeah, our voice is. I'm not sure who is talking also.
This is Natraj here.
Hi, Natraj.
Yeah, this is a fantastic session. Thank you.
Oh, thank you so much, Natraj. So yeah, I will be busy till 5 o'clock. You after 5, if you have any doubts, you can call me on my number. It's there in the group. So I would like to explain you whatever doubts we have. It doesn't matter whether it is valid or not valid. So definitely I will try to help you out. Okay, we'll meet tomorrow at 7 a.m. again. Thank you all. Thank you for your patience.
Yes, thank you, Ranjit.
Yeah, thank you.
Nice session.
Yeah. I will record. I will put it this session in the drive, and I will link up that one in the group. I will share that link in the.
Okay. Would you share the PPT as well?
I will try to share. Maybe this is my internal this one. So I will try to share individually. No problem if anyone, but not in the groups. So yeah.